All right, good morning, you guys. Today we're taking on surface area and volume of pyramids. So before I begin, I just want to show you some examples of some nets. So here is a net for a square pyramid. So here's my base. These are the triangular faces that will fold up and make it look like a pyramid. Okay, another example for a net. Here's a net for a pentagonal pyramid. Here's another way you could make a net. This one is for a hexagonal pyramid. So here, if I make this my base, all these parts will fold up together. Just kind of give you a kind of an overview of how it will look like that, and it will make a pyramid. Okay, so let's go over some vocabulary. So first, a pyramid is a type of polyhedron. All of the faces are polygons. There are edges to all the faces. So it is a type of polyhedron. It has one base. That base is going to be whatever polygonal shape. It could be a triangle, it could be a square, it could be a hexagon. And all of the lateral faces are triangular. Okay, so a type of polyhedron with one base, and all of those lateral faces are triangles. Okay, like prisms, we name a pyramid by the shape of a base. And again, just a reminder that it could be any type of polygon. Okay, we can also, just like all of the other solids we've been looking at, we can classify as right. We can classify as oblique. Okay, so if it was oblique, it just has that slanted appearance to it. But in this class, we really are going to focus on our right pyramids, just like all the other shapes. So focus on the right pyramids. Okay, so going into some vocabulary. So for my model, I'm looking at a square pyramid. And it's a square pyramid because its base is a square. Okay, so this is one way to look at it in 3D. I also built a model like this just to help you guys see some of the relationships a little bit more clearly, especially the right triangles that exist within them. So I'm going to show you those in just a moment. Just wanted to give you another perspective of a square pyramid. Okay, so first just some vocabulary. So here, that point at the top, we call that its apex. Okay, right here, that is a lateral edge. So that would be with my model. Right here would be the lateral edge. Right, that's my apex. Here's my lateral edge. Okay, each of these triangles, these side faces, each of those is a lateral face. Okay, that square bottom, right, that is our base. Okay, and then right here, this would be an edge of my base. All of these would be base edges. I also want you to visualize the net. So the easiest way to draw a net here is to start with a square base. So there's my one base, happens to be a square. And then I have four triangles. I have four lateral faces. They're all triangles. And I have as many lateral faces as I have sides to my base. Okay. So now let's move on and look at a few other relationships inside of our pyramids. So we're going to need to know all of this vocabulary to help us solve for surface area and for volume. So when I look at this model right here, so that's what I'm trying to achieve with my toothpick model of the pyramid. So right in here, if you look at my model, this red part is its height. It's that perpendicular segment that connects the apex to the center of the base. So that is the height of it. Okay, over here, this black part is what we call a slant height because it appears slanted. But if I rotate it like this, you can see that it's really just the height of one of those triangular lateral faces. But when I rotate back like this, you see that it has that slant to it. So we call it the slant height. And then here, this other leg of the right triangle is an apothem because it connects the center of the base to a side. So right here was the height, a little lowercase h, connects that apex to the center of the base. So that base was a square. Okay, here is the slant height. Let me again just rotate it. So you can see that that black segment is really the height of one of those lateral faces. And we show that with a little cursive L. That's my slant height. To make that clear, when I look at the net, the slant height would be just like this, right? It's the height of one of those triangular lateral faces. So right here would be the slant height. Okay, and then right here, center to here to a side, that is my apothem. It's a little lowercase a. So here, if I just pull that right triangle out and just draw it separate, here is my height, here is my slant height, here is my apothem. Okay, there is another right triangle that exists inside of any pyramid that has a regular base. So here, if I go back to my model, here I have connected from the center of my base to a vertex of the base. Right here, I have connected right in there. That's a radius. So that radius, when I look at the height, which I have in red, and I look at a lateral edge, I have another right triangle that emerges. So that is what I'm trying to illustrate over here, that this is still my height. This is here a lateral edge. And then right here, center to a vertex, that's a radius. So here's my height, here's the lateral edge. Okay, and then here is my radius. All right, so we should be good on vocabulary. A little bit more. So when we have a regular pyramid, each base is a regular polygon. So that just means that all of the sides, they have to be perfectly congruent. So each base is a regular polygon. So all of the sides are congruent. Okay, the lateral edges, so if I go back to my model, so my lateral edges here, 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 they would all be congruent as well. And then each of these lateral faces, if my lateral edges are all congruent, okay, and then all of my base edges are congruent, well then each of these lateral faces, they have to be isosceles triangles. Congruent isosceles triangles. Okay, and then the height of a lateral face, so the height of a lateral face right in here, that height, right, we just call that a slant height now. Little cursive L. All right, so for surface area, so if I go back and I look at my net for it, I see that I have my base, and my base could be any shape, And then I have all of these lateral faces. They're all triangles. So let me picture those triangles as a strip of 4. So I know that here, these are all of their collective base edges. So together, it's my perimeter of whatever my base shape is. In my model here, it was a square. And then here, if I draw in the height for one of those individual triangles, remember that that is our slant height. So when I'm running through my formula, I know that surface area, in general terms, is the lateral area plus 1 base area. But my lateral area, I can picture it as a strip of triangles. Each triangle would be 1/2 the base times the height, but I'm going to take all those bases together and call it my perimeter. So I'm going to say 1/2 the slant height times the perimeter, and then plus whatever that base area is, because we know that it can vary, right? My base shape could be an equilateral triangle. It could be a square. It could be regular hexagon if I'm talking about a regular pyramid. So here again, that cursive L is the slant height. The P is the perimeter of the base. And the B is the base area. Okay, volume. So volume, if we're looking at a pyramid, let's say that I look at a pyramid here, okay, a pyramid and a prism side by side. So if you look at these two, they have the same base shape. The bases match perfectly, okay, and they have the same height as well. So if we were in class, what I would actually do is I would have a container of water and I would pour here water from my prism into my pyramid and look at how much space is being occupied. And what we should see is that this volume will end up being 1/3 of what it would have been if it was a prism with the same base shape and height. So we know that a pyramid then is 1/3 what it would have been as a prism, same base, same height. If I have time, I'll make another video just to illustrate that. So volume is 1/3 the base area times the height of what it would have been had it been a prism with the same base area, same height. So again, that big B is for base area. And the H is the height of the pyramid. All right, so a few examples. So first here, I'm just having you find the specified measure. We're assuming that we're looking at a right regular pyramid, because again, that's the focus in this class. So here I see that my height is the 8. I can see that right here, the apothem must be 6 because a full side here is 12. And I can right away recognize this as a special right triangle. It's a 3, 4, 5, but doubled to be a 6, 8, 10. So my slant height, I didn't even have to use Pythagorean theorem. I could see it pretty clearly. My slant height has a measure of 10. Okay, for B, here I'm solving for the height. So right there, I want the height. So here I can also recognize another pattern. I can see that right here, this leg, if I call that X, I can see that the hypotenuse is 2 times X. So that signals to me that this is really a 30, 60, 90 triangle, where this is the short leg, which is X. This would be the longer leg, which is X times the square root of 3, and the hypotenuse is the 2X. So here all I'm going to do is take that 4 root 3 and times root 3, which is 4 times 3, which gets me 12. So the height has to be 12. If I did not see that, I could always use Pythagorean theorem. That's not a problem. It's just that we have some shortcuts that are built in. Okay, next one, I want the apothem. So right here is the apothem that I'm going to solve for. So here I do have to use Pythagorean theorem. I don't recognize any special right triangle or a common Pythagorean triple. So here, Pythagorean theorem it is. 8 squared plus a squared equals 12 squared. 64 plus a squared equals 144. Take away the 64 from each side. A squared equals 80. Take the square root of each side. 80, I know that that is 16 times 5. So I know that it will be plus or minus 4 root 5. But it has to be the positive 4 root 5. Okay, and then lastly, here I want a lateral edge. So what I've given you, though, I've given you a base edge. I've given you a height. I want the lateral edge. So I actually need to get to a radius first. So what I'm going to do is I'm just going to give myself a little top view of the base. So I'm going to draw out that square. And remember, this is what I want. I want that radius right there. So I know that this whole side is 8. So if that whole side is 8, then I know when I draw on this triangle that this is 4 and this is 4. And in fact, this is 4 also. So I can see that I have a 45, 45, 90 triangle, or an isosceles right triangle. So this part right here would have to be 4 square root 2. So for an isosceles right triangle, a 45, 45, 90 triangle, we know it's x, x, and then x root 2. So my radius right here is 4 root 2. Okay, and now to get to that lateral edge, right here, I'm using Pythagorean theorem again. So I have 4 root 2 squared plus 10 squared equals x squared. So 4 times 4 times 2 is 32, and then plus 100 equals x squared. X squared equals 132. Take the square root of each side. I know that that's 4 times 33. So that means that I will get plus or minus 2 root 33. But again, it has to only be the positive. So x, the lateral edge, has to be 2 root 33. All right, please flip to that second page. All right, we only have a couple on the back, or 3 on the back. All right, find the surface area and volume for the right regular pyramid. So first thing that I have to take stock of is just what is it that I actually know. So I know a slant height, and I know here a base edge. So let's focus on our base first. So let me look at that base that's a triangle. So here I have a triangular pyramid, and that base has to be an equilateral triangle. So let me make it nice and big. Okay, each side is 12. And I know that my area will be 1/2 the apothem times the perimeter, and I can already see that my perimeter will be 36. I have 3 sides, they're all 12. So now, here, I could do 1/2 base times height. I could do 1/2 AP. I already decided to go 1/2 AP. So I need my apothem. So let me draw that in, and then I'm going to draw in a radius as well. So we know that right here would be the 30, and here would be the 60-degree angle. So here is x, here is x root 3, and here would be my 2x. So that means that right here, if each side is 12, this part right here would have to be 6. So if 6 is equal to my x root 3, and I want x, I need 1/3 of it, and I need to multiply by √3. So I get my apethum at 2 √3. So if I plug in that 2 √3 here, I'm taking 1/2 times 2 times square root of 3 times 36. And I end up with 36 √3 units squared. So that's my base area. And I need that. I need to have that perfectly correct before I proceed, because if I make a mistake there, I'm going to make a mistake on surface area and volume. So let's look at surface area next. So surface area, I'm taking 1/2 the slant height times the perimeter plus the base area. Now, I already know what my base area is. I know my slant height. I know my perimeter. So great, I have all the things that I want. Slant height is 16. Perimeter of the base was 36. And the base area, already solved for it, 36 √3. So 1/2 of 16 is 8. 8 times 36 gets me 288 plus 36 √3 units squared. Okay, and then lastly, I need to get to volume. So volume is 1/3 the base area times the height. So I know the base area, right? I already got that. I know the base area is 36 √3, but it's my height that I don't know. So I have to go back to that right triangle relationship, where this is my apethum, here's my height, here's my slant height. So right now, what I know is that my apethum is 2 √3. My height, I don't know. My slant height is 16. So I have to use a little Pythagorean theorem to get to my height. So I know that 2 √3 squared plus the height squared equals 16 squared. So 2 times 2 times 3 gets me 12, plus the height squared equals 256. Take away the 12 from each side. My height squared equals 244. Take the square root of each side. 244 will be 4 times 61. So my height would be plus or minus 2 √61, but it can only be the positive. So the height is 2 √61. So that is what's going to plug in right here. So I'm taking 1/3 times 36 times √3 times 2 times the square root of 61. So when I multiply here and here, 1/3 times 36, that gets me 12. 12 times 2 gets me 24. Okay, the square root of 3 times the square root of 61, there's not going to be any pair between them, so I multiplied them back underneath the radical. So 3 times 61 gets me 183, and then my units are cubed. Okay, next up, find the surface area and the volume of the composite solid. So first, I need to think about, how do I get to these parts? How do I get to my surface area first? So I'm looking at, here's my cube, and I have a pyramid, but it's upside down and cut out of the cube. So I'm trying to picture what surfaces are exposed, because this is actually rotated too, kind of like that. So let's look at each surface. So let me just make a plan. So surface area. I would start with my cube. So starting with the cube. And then I'm cutting out, right here, I'm cutting out the pyramid base. So minus the pyramid base. Okay, but now all of those triangles are exposed. So here, all of these triangles are now exposed faces, so I have to add them all back in. So I'm adding back the pyramid, lateral area, all of those 4 triangular faces. Okay, so if I lay out my formulas first, I know that my cube, 6 times a side squared. My pyramid base, well, it's just a square, so it's got to be base times height, or a side squared, could write it as x squared also. And then my pyramid lateral area is 1/2 the slant height times the perimeter. Okay, so I know exactly all the things that I'm going to need. So if I look at my figure, let's say I picture a top view of my figure. Let me draw the top of the cube. So here is a big square. And then here, just connecting all these midpoints like so. Okay, I'm going to see that here would be 4, 4 all the way around. Because each full side has to be 8. So then I see, oh, I have all of these 45, 45, 90 triangles, or isosceles right triangles, where all of these have to be 4√2. Okay, so again, this whole part was 8. Okay, so now I have all the stuff that I need to keep going. So I know that, let's see, the cube, each side is 8. So let's start there. Plug in an 8. Okay, my base of the pyramid, I know that that's going to be the 4√2 and the 4√2. Okay, I know the perimeter. I don't know the slant height, so I have to go back and figure that one out also. So my perimeter, if I add up those 4 4√2s, I have 16√2. So let's go back and let's figure out how to get to the slant height. So if I draw my pyramid, when I draw it, I always try to draw it kind of slanted like that just to help me see the dimension of it. So that's my square base, even though right now it looks kind of like a parallelogram. I'm going to put my apex right here, and then I'm going to connect to these corners in the front, and then the corners in the back. So I've drawn my pyramid. I'm going to draw in my height first, just like that. And then I'm going to draw in my slant height like that, and the apothem like that. So right now, if I know that each side here is 4√2, I know that here is 2√2. Okay, I know that the height, well, the height of the pyramid and the cube, they're both 8, so the height here has to be 8. So I need to figure out my slant height right there using Pythagorean theorem. So I know that 8 squared plus 2√2 squared is going to equal my slant height squared. So 64 plus 2 times 2 times 2, well, that gets me 8 equals the slant height squared. So I'm going to get 72 equals the slant height squared. I'm just going to flip it. I like seeing my variable on the left. So my slant height squared equals 72. Take the square root of each side. 72 is 36 times 2. So I'm going to get plus or minus 6√2. But I know it has to be the positive 6√2. Okay, so now I have everything that I need. My slant height here was 6√2. So if I have 6 times 8 squared, 6 times 64 gets me 384. 4√2 times 4√2 is 4 times 4 times 2, so 32. Okay, 1/2 of 6 times 16, and then times 2. So I'm going to end up with 96. So if I take 384, subtract 32, add 96, I get 448 units squared. That would be all of my surfaces all added up. Every surface that's exposed all added up together. Okay, volume. So to get to the volume, that's a whole lot easier. I just have to take my cube, right, here's my cube, and then I just have to cut out the pyramid. So cube minus pyramid. So my cube volume is a side cubed, and for my pyramid, My volume is 1/3 the base area times the height. So my sides are all 8. 8 cubed is 512. Okay, my base area, so my base area of the pyramid was the 4 root 2 times 4 root 2, so 32. And the height of the pyramid is 8. So if I take 1/3 times 32 times 8, I'm going to get a fraction. I'm going to get 85 and 1/3. Okay, so one more step, 512 minus 85 and 1/3, and I end up with 426 and 2/3 units cubed. All right, last one here. A square pyramid has a height of 13. Volume is 156 centimeters cubed. Find the length of a base edge. Okay, so square pyramid, let's draw it. So I'm going to draw that square base, right, to give it dimension. I make it look slanted like a parallelogram. Here's the apex. I'm going to connect to each of those corners, give it some dimension. All right, there's my square pyramid. We know that its volume is 1/3 the base area times the height, and we're told that that volume is 156. Okay, we're told that the height is 13, so the height here is 13. Let me go ahead and draw that in. So the height here is 13. So let me label that here 13. Okay, so right now I have 156 equals 1/3 the base area times 13. So here, I'm going to solve for the base area. I think that's going to lead me to my length of a base edge, especially if it's a square pyramid. That base shape is a square. So let me solve for the base area first. So maybe I clear my fraction, multiply each side by 3 just to start. That would clear the fraction here. So I would have 468 equals 13 times the base area. Divide that 13 next, and the base area would be 36 units squared, so centimeters squared. There's my base area. So remember that that base shape is a square, so all of the sides have to be the same thing. All these angles have to be right angles if it's a square. And I know that its area is 36 centimeters squared. So then I know that the base times the height, x times x, will equal 36. So x squared equals 36, right? Trying to get to that base edge, solve by taking the square root. X could be plus or minus 6, but we know it's only the positive, so we get 6 centimeters for our base edge. All right, that takes care of our pyramid. I hope you guys have a good rest of your day.